So what we're going to do in this video is just some basic setup of using Mach 3 and talking about coordinate systems. And so there's two coordinate systems. Every machine that I've ever met, but I know that there's an exception to the rule, but basically every machine that I've ever met has two coordinate systems. One of those coordinate systems is a machine coordinate system, and the other coordinate system is the what we refer to as offsets. But the basic offsets are G54 through G59. Those are called a work coordinate system, or the part coordinate system, or a fixture coordinate system. They can be called different things, but they're all the same thing. They're all used G54 through G59, and they're offsets. And the reason that they're called offsets is because it's a distance away from the machine coordinate system. So those are the explanations that we're going to go through today and try to cover it using Mach 3 and using the keyboard. The one coordinate system, the first and the most important one, is this machine coordinate system. And what that is that's the physical limitations of the machine, or the working envelope of the machine. X, Y, and Z. There's like a rectangular box on the machine. You can't see it, it's imaginary, but that creates a coordinate system. So the blue here is the machine. If you can envision, the bed of the machine is all in the blue. And if you drew out X, which is the front of the machine, and then the Y-axis, like from front to back, and then the Z-axis is up and down, you end up with the machine coordinate system is right here. This is the 0 point for X and Y, and then with the spindle all the way up into the top, you see the Z. I put this bar, that mark over there for the Z. That's the machine coordinate system. That's when you home out the machine and it all goes to X, Y, Z, 0. That's when the spindle is going to be at the very top, the tippity top, as high as just the spindle can go, and all the way over to these limits over here. Some machines have limit switches, which I'll explain in a couple of minutes, and I'll show you how that works. But some machines have limit switches, and when you tell the machine to go home X, Y, Z, 0, it's going to move all the way over to the X 0, all the way over to the Y 0, all the way over to the Z 0. Not necessarily in that order, but they will move all the way over to those home positions. If you don't have limit switches, then you have to set that machine 0, the machine coordinate system, in the software. Like in Mach 3, you can set it up in the software. Then the second coordinate system is this work. This is when you put something on the bed in the machine. The little black rectangular is the work coordinate system, and that's all with G54, G55, so I put a GXX, whichever G system you use, and the machine most often defaults to G54. That means when you start up the machine, it's already automatically looking for G54 as a work coordinate system. And that's the one that you have to set all the time. The machine coordinate system, you don't set that all the time. You set that once. If you don't have limit switches in the machine and you set that up, you only set that up one time. You don't set it up anymore. It just stays right there. And then the work coordinate system, you set that every single time you put something on the machine bed. You have to set that up. That's G54 through G55. And it's called an offset. because it's a distance away from something. And that distance away from something is that machine coordinate system. So you have some distance away in the X direction, there's some distance away in the Y direction, and there's some distance in the Z direction. Those are the ones that we're going to use all the time. Every time we're going to put something on the machine, we use that work coordinate system. We have to set that every time we go to make something. And show you the proximity sensor for the that's used for the machine coordinate system. And in the machine right there you could see that little sensor that I showed you, and what it does is that moves across to this little metal strip. Now on my machine this is pretty, I mean, it's not as sophisticated as some high-end machines are, but it works. I mean, it's just like, that's just a metal strip. It's not a ground. It's just a metal strip. It could be a plastic leg or a wooden leg, and it wouldn't matter. But you can see the light on the top, and focus that in. You can see the light on the top that's lit, and I'm not sure if the light goes out. Maybe it does. We'll try it a little while. But that moves across. This is my y-axis that moves back and forth. You can see the y-axis symbol there. And there's two other ones. There's one on my x-axis, so that there's the little metal strip right there. I don't know how we're focusing on it, but there's a little metal strip right there, and up underneath you could see that sensor right there for my x-axis. See, I even marked an X on it. And then there's one more sensor that I'm going to show you on my z-axis. So my z-axis moves up and down, and at the top of the z-axis right there, come on baby, focus, there's the proximity sensor, and there's the little metal strip. So as that moves up to that, the machine senses it. So all of those sensors are all tied into this breakout board right over here, and these lights on the breakout board, these lights are the ones that light up for the sensors. So I'm going to go click that on to machine coordinate system, because I want to watch that display. And then I'm going to go over to this little bar on the side over here. It says Ref All Home position. So now I'm going to press the Ref All Home and watch the machine go to its home positions. Okay, so just one more time we're going to do a Ref All Home and look at machine coordinate systems. And this is the last time we're going to talk about machine coordinate systems, because then after this we're going to talk about setting up the work coordinate system. So let's take a look at this one more time, and you can see how the limit switches work. So here we are looking at Mach 3 again, and one more time I'm going to go do Ref All Home, and this time we're going to go look at the limit switches. So right now the Z is moving up, and we're going to watch the little metal tag, go up to the proximity sensor. I believe it's magnetic. Here we go. As that puppy goes up there. Now it's moving in the Y direction. And this one here on the side of the machine is the little metal tag I showed you earlier. And there's the proximity sensor. Let's look inside the control and see what happens. I believe the light flashes when it makes contact, but let's watch it. Did you see that light flash? X, Y, and Z 0. And incidentally, one thing to note is that when we're talking about the position of the machine, that's the very center line of the spindle. So this X and Y, what it's really describing is the center line of the spindle. I know that's not where the proximity sensors are. It doesn't matter, because what we're doing is we're looking at where the center line of the spindle is. And the spindle goes all the way up at the top. That's not any relationship to anything on the spindle except for where that proximity sensor is. But it doesn't matter. It's just a place. It's just a distance, something in space. Okay, so what we did there when we said ref all home, we sent the machine 3 axes to the extreme limit of the machine working envelope. That's the hard limits, the absolute end of the stroke for the machine itself. And that was this little spot right here in the X and the Y, and with the spindle all the way up as far as it can go to the Z. So we just watched the machine do that, and it went to the home positions, and on the display with the machine coordinates, we could see that the display went to 0, 0, 0. So that's the beginning point, the start point of the coordinate system for the machine. So just like any Cartesian coordinate system, there's a 0 point, everything this way is negative, everything this way is positive, and then there's a 0 point, everything this way is negative, everything that way is positive, and then the Z, the 0 is all the way up the top, so that everything negative is down, everything positive is up. Can't go up anymore, it's gone as far as it can go. It can't go X minus anymore, it's as far as it can go, and it can't go Y this way anymore because it's as far as it can go. It's up against the limit switches. So let's take a look at what we mean by offsets when we talk about G54, G55, and so on for the work coordinate system, and we'll look at what that actually means. Okay, over here what we're looking at is the machine coordinates that's lit up with red. A little box around it says machine coordinates. I moved my x-axis and my y-axis 0.0298, about 1/32 of an inch. I moved it in the y direction and I moved it in the x direction. The reason I did that is just to move away from the limit switches, because if I didn't do that, I could have some errors with Mach 3 if they stay on the limit switches and you start moving the machine around. It can cause a little bit of an issue. But if you move away from the limit switches, you'll be just fine. So that's what I did. That's why the X and the Y are at different positions. But I moved the Z axis down so that it touches the tape that I put on here, just above the tape, just a tiny little bit above the tape. And you can see my Z is minus, because of course minus is down, we talked about that. Minus is down, and it moved down how far? It moved down from Z0 being the very, very top. I moved that little pointer that I have in the spindle, I moved that down so that it touches the tape, and that distance is 11 inches, 615 thousandths, 600, almost 16 thousandths. That's the distance that we moved down. Keep that in mind because we're going to measure the distances to get to our work coordinate system. And this is just the beginning. I want to explain that to you. That's how far we are away from the machine coordinate system Z0 to the top of the tape with the tip of the tool that I have in the spindle. Of course, the spindle can go down a little bit further. If I bring the collet down, it'll go further, but because I have a cutter in the spindle, not a cutter but a pointer, it's the tip of the tool has moved down 11 inches, 616 thousandths. So now that we're going to talk about the work coordinate system, we've set up and we've finished looking at the machine coordinate system. Now we're going to look at the offsets for the work coordinate system. So here I have a piece of work. Yeah, I know you're all saying I'm a piece of work. But I'm going to magically just toss this on the machine and it's going to end up exactly in this little corner right here. I didn't plan that. I just put it on the machine. Didn't premeditate anything. It just put it there and that's where it ended up on the machine. Some random place. It just happens to have landed right here on these marks that I made. Lucky me. Okay, so now before I go too much further, I have to explain how we can move the machine the way that we want the machine to move. Sometimes it moves too fast or too far, and we want to slow it down and control the motion of the machine when we press the keys on the keyboard. So there's one key on the keyboard that brings up what they call a manual pulse generator, or MPG. And if I press the tab key on the keyboard, which I'm going to do right now, got the keyboard, I'll press the tab key, but watch the screen and something just appeared. So that thing that appeared on the screen, there's this area here that I want to look at. Of course there's a dial up at the top. We're not going to look at that too much right now. But what I want to do is I want to look at this area right in here that is going to help us to be able to control the machine. And there's a bit of stuff going on there, but it's not that much and it's not that bad, and it's something that we can deal with pretty easily. And I can use my fancy dancy pointer. Made it special just for this video. But anyway, you can see the little mouse moving around as well. So what I got here is there's this thing called Shuttle Mode. I don't know what that is. I've never tried it, never worked with it. The next thing down is the Cycle Jog Step. That's this button right here. And if I click on this one that says Cycle Jog Step, there's a display here. And right now I have it displayed in inches, which is how everything is set up here. But if you were set up in millimeters, I'm sure that there would be some coordinated way. I've never done it on millimeters, so really don't know, but I'm sure that it works in a very, very similar way as inches. So if I click on this Cycle Jog Step, So when I click on that button, watch what it does to this display over here. It changes the increments. You see how that changes increments? In inches, it goes all the way down to 1/10,000th of an inch, which on a machine like this doesn't really mean anything to us. But if I click it again, it goes to 1 inch. So every time I press the arrows or the page up, page down, the spindle will move down 1 inch, or the X will move over 1 inch, or the Z will move over 1 inch. If I click it again, it's 0.1 inches, 100,000ths of an inch, the same thing. Change my increment to 10,000ths of an inch. I can change my increment to 1,000th of an inch, or I could change it to 1/10,000th of an inch. The next, I'm going to put it on 10 thousandths right now. 0.01 is 10 thousandths of an inch. The next button down right here says Jog Mode. Right now it's on CONT, continuous. If I press it, it goes to step. When it's on step, that means every time I push the arrow key or the page up or page down, it's going to move one step, just one amount that I have set here. So right now, if I press, if you could see the display. Let's back out so you could see the display. Let's move that a little bit. I want you to watch the display. Here we go. So I'm going to press the page down. You can see my Z. As a matter of fact, what I'm going to do is I'm going to make these all 0. I don't care about this one. I'll make it 0, but it doesn't matter. I'm not using it. So now if I press my Z down, it's going to move 10 thousandths of an inch. It's rounded out to 10 thousandths. The 0.0002 is about as big as nothing. If I move it up, it goes up, it went up 10 thousandths. Now if I move my y-axis, that moves 10 thousandths. Another 10, another 10. Well, I'm going to make that 0 because we're just measuring things, and we can do this to measure. Now if I go back over to this increment amount right over here, Jog Step, and I move that to 0.001, I'm going to move my axis. It moved 0.001. If I move it back again, it goes back to 0. I can move it minus. I need to change my display so it reads just 3 decimal places, because the 4th decimal place on a machine like this, it doesn't really matter. 2, 3, 4. If I move my Y, 1, 3. If I move my Z. By the way, how thick is a piece of paper? A piece of paper is 3 thousandths of an inch thick, about. Your hair on your head is also about 3 thousandths of an inch. Even people with thin hair or thick hair, it's about 3 thousandths of an inch for each one. So that's how you change over here. And then if I go to my jog mode over here and I change it to continuous, when I move my axis, watch what happens. If I hold the button down, I move my axis back and forth. You can change how fast that axis moves by these other buttons at the bottom over here. This one here, slow jog rate, this amount here, 10%. If I move it to 50%, we'll see how fast it goes. 50% of the fastest move that it can make, I guess. You can hear the difference. Of course, I can see my machine. I know I'm not going to crash. Now, if I go and move that back down to slower, you can hear the difference in the machine. And then I have these other buttons down the bottom here that I can press those buttons with my mouse and move the machine around. You can see the movements there. Okay? So, with these buttons here, you can control all of that. This here I don't use. The Shuttle Mode I've never used. I don't know what it does. These things up here, I don't know what they do. I've never used them. But this here is what I use most of the time. This Jog Mode, step, continuous, back and forth. You can go to step, and I'm going to 0 again. Step. I'm going to hold the button down. And I'm still holding the button down right now, but it only moved 0.001. I'm going to release the button and press it again. Release and press again. So each time I press the button, I move that increment right there. So again, I can change that. I can make it 1 inch. We'll change this. I'm going to move 1 inch. I just press the button and let go. I press it again and let go. And that's what it does. If I press it in X and let go, press it again. So that's how, with these buttons here, this is how you control that. Cycle Jog Step changes the increment. Jog Mode, go to either continuous or to step. Continuous, it just keeps on going as long as you hold the button down. You let go of the button and it stops. So that's that. That's how I move the machine around. Okay, so now I am going to use the keyboard with the arrow keys to move the machine over so that my pointer is right to the corner of my work that magically landed in that spot where it is right there. Now I'm going to change the manual pulse generator using the tab key and my mouse to change the step, continuous step, and step increments in order for me to bring that right down to the corner. And then we're going to look at the display a little bit more. I'm going to change my steps to a finer increment. It's 0.001, 1/1000th of an inch per each time I press the button. Okay, so you could see I did not use a piece of paper. I did not use any kind of measuring device. I did that all by eye and by touch and feel. And most of the time, for working with wood, that's perfectly okay. Doesn't have to be exact, unless you have more than one tool that you're going to be using and you want each tool to go to an exact position. Then the Z for the piece of paper would probably be more accurate. But this is just done by eye. Okay, so I have the pointer right on the corner of my workpiece, and all I need to do, I don't need to do anything else. All I need to do is just to zero out these three axes. The machine coordinate is off. That's not displayed right now. This is just the G54. This is the work coordinate system. And all I need to do is to click X, Y, and Z. That's all I need to do. I'm all set. I'm ready to run the part. Nothing else needs to be done, except change the tools and things like that. And if I change the tool, I have to redo the Z, because every time I put a different tool in the spindle, I have to go and touch off that Z in the same place all the time. So if it's the top of the material, I set my Z for my new tool on the top of the material. The X and Y, we don't change those. As long as we're still working on the same workpiece, that stays the same. The only thing that changes is when I change the tool, I have to change the Z and reset that Z on top of the workpiece. That's because the tool is always a different length, and it's different from the spindle down. So if I look at machine coordinates, I could see that magically that piece ended up to be 12 inches away from the machine coordinate system and 15 inches away from the machine coordinate system in the X and the Y. That we don't ever change. That always stays. If I put that in a different place on the table, it would just be different numbers over here in the machine, because the machine is always going to come to the same place, X and Y. That's what I drew on the table. That's what I drew on the machine coordinate system on the whiteboard. So that can change all over the place, as long as when we shut that off, that lower left corner and the top of the material for the workpiece is at 0, 0, 0. That's what it is. That's where it's going to go. That's it.